Our learning target for today, we are talking about angles formed by transversals. So we'll be discussing what a transversal is. So I need you to be able to look at a picture. A transversal is a type of line, so I need you to be able to look at a picture and say, hey, that's the transversal in this picture. And I need you to recognize a special pair of angles. A new special pair of angles, corresponding angles. Last class we talked about 3 special pair of angles. I challenge you, without looking at the screen or looking at your page, can you remember the 3 special pairs of angles that we discussed in our last class? Supplementary is one. And remind me, what's special about supplementary angles? They add up to 180. What was another one that we looked at last time? Complementary angles. And what's special about complementary angles? They add up to 90. And then the third one, which was new to most of us, was vertical angles. And how do we spot those on a picture? What are they going to look like? They're like across from each other. When 2 lines cross, they're like across from each other. And what's special always about vertical angles? They're equal. Okay, so right now we only have 3 of these. There are going to be like 8 of them before we get done with all this, and it's going to start kind of blending together. So hopefully, again, you guys are taking advantage of this wonderful pink packet that I printed off for you all, and filling in some of that stuff. If you haven't already, maybe at the end of class today, you can go ahead and fill in the stuff for supplementary, complementary, and vertical. And while you're at it, you will be able to add corresponding angles to your work from today. So today, our big goal is, can we recognize a transversal? And then in a situation with 2 lines in a transversal, can we find pairs of corresponding angles? And what's special about them? So we'll have 4 special pairs by the end of today. Let's go ahead and flip to our lesson. All right, so it starts off with a kind of a story, and I cut a lot of this off from what's in the book to save some space, but there's a story about Marco, and Marco was walking down the street, and he saw this mural that had these parallelogram tiles, and there were like hundreds of them. And he made a quick sketch of a few of these, and they all kind of all fit together. And what this is asking us to use is use different colors to mark angles that are the same measure in the figure. So for example, and if you don't have colors, you could use different shapes, which I'm going to do. I'll use shapes and colors. For example, there's an angle down here. I'm going to start with this one right here. I'm going to put a little smiley face in that angle right there, or some other shape, some other symbol. Can you identify any other angles in this picture that would be the same as that smiley face angle? Is there a vertical angle right across from it that would also be the same? Yeah, if it's the same measure, we're going to use the same color, same symbol. So let's put a smiley face there too. Are there any other vertical angles for those smiley faces other than what we've marked so far? Answer is no, there are not. But we've got tracing paper, and this is why I had you get tracing paper today. If I trace this angle right now, this is my smiley face angle, I could try moving it around and see if it matches any of the other angles. And I bet some of you could have probably told me that this one was going to be the same without using the tracing paper, right? But now that I've used the tracing paper, I have confirmed this one would also be the same angle. I'm going to put a smiley face there too. And I guess I might as well put one here too. I kind of feel like this one down in the corner might be a smiley face angle too. What do you think? I can test it. If I'm not sure, I can test it with my tracing paper. Yeah, it matches up perfectly with that if I flip it around just right. All right. Now, what about this one down here? Is that the same as this as the one that we've been looking at? If I put my smiley angle up there, it's definitely not the same. Let's give this one a different color and a different symbol. I don't know. I'm going to go star. And I'm going to look for some other star angles. Let me trace this just so I have something that I can use to hold up and confirm. I kind of feel like this one over here is going to be the same. You think? Let's test it. Totally the same. So here's what I want you to do. Finish going through there and see if you can put smiley faces and stars or different colors or whatever you want to do, but mark all of the angles that are the same with the same symbol or color, and then any other angles that are the same, a different color, different symbol. Go through and mark all those, and then we're going to come back and talk about transversals and corresponding angles. There's a lot of angles in this picture. This is kind of tedious. There's another one. I missed this one. All right. All right, so what we're trying to see here is there's basically two angles going on in here, just repetitions of those two. There are, I see in this picture, I see vertical angles. We already talked about that. What other special pair of angles that we know about do we also see in this picture? I see vertical angles. For example, these two purple stars are vertical angles. Do you see any supplementary angles in this picture? Yes, I hope you do. There's lots of supplementary angles in this picture. For example, this smiley face and this star would be supplementary angles, wouldn't they? Aren't they forming a 180-degree angle, half of a circle? Do you see some other supplementary angles in there? If I asked you to count how many pairs of supplementary angles are there in this picture, how big would that number be? Would it be less than 10 or more than 10? More than 10. There's a lot going on in this picture, right, that are supplementary. I do not see any complementary angles. I don't see any 90-degree angles at all here, but I see supplementary. I also see corresponding angles. I see a lot of different pairs of corresponding angles, but we don't know what those are yet. And that's going to be our next goal. Actually, first, before we do that, I need to teach you what a transversal is. So I want you to look at, we're going to focus in, this is basically like a zoomed in version of just like this part of that picture right there. Okay, so I've got, this is kind of, we would have labeled this with a star and this with a smiley face a minute ago, but we're going to think of them as individual angles right now. We've got these two parallel lines, and then this angle that connects and cuts through those two parallel lines, this line is called the transversal. So a transversal line is a line that connects and cuts through two parallel lines, or any two lines in general. All right. So are we feeling okay about transversals? Let me give you a quick test. I am going to draw 3 lines, and I'm going to label them. And I want you to tell me which of those lines is the transversal. Which one's the transversal, A, B, or C? B is the transversal there? All right, you guys are pretty good. You're pretty good. Let me see if I can trick you on this next one. Which line is a transversal in this picture? Oh, is it I didn't trick you. Wow. So you know that even though this one's like going sideways and this one's going up and down, this is the transversal because it's the one connecting them. All right, now this next one I'm going to trick you. I got this. You ready? Which one's the transversal here? Yes, line Z is a transversal. Y is also a transversal. Yes? They're all transversals. Right? So it just kind of depends on how you're focusing your attention. If I focus on that part of the picture, W is clearly the transversal, right? If I focus down here, Z is a transversal. If I focus up here, Y is the transversal. If I tune out line W, X is the transversal. So they can all be thought of as the transversal. So if I were to ask you in this picture up here, how many transversal lines are there? There's a bunch. There's a bunch. Okay, so we got the idea of a transversal. We are halfway through our learning target for today, folks. You're doing awesome. What I need to do now is to help you understand what a corresponding pair of corresponding angles looks like. So we're going to need tracing paper for this. I am going to trace angle X. And I'm going to label it. Now this is not on your packet, but this is a little bit of extra bonus here. I'm going to wait till you guys get it traced, and I'm going to have you look up here. I am going to prove to you that vertical angles are congruent. Are you ready? Look up at the screen if you would. I'm going to take this angle X, I'm going to flip my tracing paper over, and I'm going to show you that it matches up perfectly with angle Y. Now, when I flip my paper over, what type of transformation am I doing? Yes, but give me the technical. It starts with an R. We're doing when I flip the paper, when I flip it upside down, we are doing a reflection. And remind me, please, is a reflection a rigid transformation? It is one of the three rigid transformations. And what's special about rigid transformations? They keep things the same shape and the same size. So if I've done a reflection and I'm getting the exact same angle, then they must be equal to each other. I could have also done it. So I heard someone say a rotation a moment ago. I could have also done this. I could have rotated angle X to get it matched up with angle Y as well. So there, we have two different proofs that vertical angles have to be congruent because I can get from one angle to another by doing a rigid transformation, by doing a reflection or a rotation. So here's my challenge to you. Can you go ahead and put your tracing paper back at X if it's not there already? Can you try another rigid transformation with angle X that would match it up with a different angle, not angle Y, but something else on this page, a single rigid transformation that would match X up with something else on this page? Play around with that and see what you can do. Rigid transformations, just so we're all on the same page, there's three of them. They are reflection, rotation, and what was the third one? Translation. We haven't done a translation yet. Maybe try doing a translation to see if you can transform X so that it matches up with some other angle in this picture. One single transformation. If I am only translating, I'm not flipping or spinning, I'm only moving it, what is the other angle that we can get X to match up with? B. If we slide it up here, can we get X to match up with to C without rotating or reflecting? I think we could do it with a combination of a couple different things, but I don't think we can do it without rotating or reflecting. If we're just translating, we can clearly get B though, right? All right, so angle X and angle B are what we call corresponding angles. They're angles that I can translate one angle to the other one and get a pair of corresponding angles. So it asks us in this one to name all the pairs of corresponding angles. It says other pairs. Sorry, I'm kind of skipping ahead here. We're looking at part A down here. We sort of talked through all of this, so we're skipping down to here. Let's name all the pairs of corresponding angles. We just said that angle X and angle B are corresponding angles. Can you find me another pair of corresponding angles in this picture? Is there a corresponding angle for angle Y? C, because I could take Y and slide it up here and make it match up with C. There's a second pair of corresponding angles. So angle Y and angle C are also corresponding angles. Are there any others? What do you think? Does W have a corresponding angle? What would W's corresponding angle be? If we slit it, what does it match up with? A. So W and A are also, angle W and angle A are also corresponding angles. There is one more pair of corresponding angles in that picture. Which one? Z and D. So corresponding angles are angles where you can slide one angle along a transversal and get to another one. And since we are doing a slide or a translation, and a translation is a rigid transformation, that means what about corresponding angles? Do they add up to something, or are they equal to each other? They're equal to each other. It's a rigid transformation, so we haven't changed the size of it, so it's going to be the same angle. So corresponding angles are equal sometimes. We'll come back to that in just a moment. Could you use what we know right now to fill out all 8 of the angles in this picture right here? I'll get you started. We learned last class that these 2 angles would have to be equal to each other because what type of angles are they? These 2 that I'm pointing at here and here? Those are vertical angles, and vertical angles are always equal to each other. So go ahead and put a 60 in there. We know it's got to be 60 because it's a vertical angle. What is special about these 2 angles that I'm pointing at right here? They have a special relationship also. They are supplementary, which means they add up to 180. So what adds up with 60 to 180? 120. Ooh, we got 120. Hey, there's a vertical angle from 120. We could fill that out too. There's some corresponding angles going on here as well. You can use corresponding angles to figure out what these are down here. Could you please mark so that we've got all 8 of the angles shown in this picture? Vertical angles here. I'm going to slide that down to here. I'm going to slide this 60 down to here. And we got vertical angles there, supplementary angles there. All right. So I've already told you vertical angles are always equal. I kind of hinted about supplementary angles are sometimes equal. Anybody know what could make supplementary angles, or not supplementary, corresponding angles are sometimes equal? Anybody want to guess what's needed to make corresponding angles equal to each other? That's pretty important. That's it right there. So let's flip to the next page and explore this really quickly. Let's see if we can find values for X and Y in each of these pictures. I'll start you out on the first one, part A. Are you confident that if I knew this was 135, we could figure out what X is? Are those corresponding angles? They are, yeah. So, and corresponding angles are equal, right? They look like they're equal. You can trace it if you want to and move it over. I'm pretty sure that X is going to be 135. Let's write it in there. And then Y is a vertical angle. We know for sure vertical angles are always equal, so it's 135 also. All right. What about part B, 135? 135 and X, those are corresponding angles. No, they are. I'm telling you they are. If I took this angle and slid it along my transversal, this one's in the same position. They are corresponding angles. Okay, they definitely are corresponding angles. What's not true about these corresponding angles? They're not the same. Okay, so corresponding angles are not always the same. These are, yes, they are corresponding angles, but they're not equal. I don't know what X is. I don't think I have any way of knowing what X is. What's the difference between the picture in part A and the picture in part B? And you nailed it just a second ago. We got parallel lines here. We don't have parallel lines here. So this whole thing with corresponding angles being the same, they're not always the same. In order to be the same, we got to have parallel lines. So I do not know what X is. I can find X in this one because I got parallel lines. Can you guys go ahead and figure out what X and Y are in part C? And then I think in B and D, there is some stuff we can find. Find as many things as you can in number 17 here, and just leave question marks for any of the ones that we're not sure about. Parallel lines, so they are corresponding, which means they are equal. 135, what does 135 add up with to make 180? 45, thank you. Hooray. That would be 45. Can we find B in part B? Can we find Y? Supplementary angles. Supplementary angles always add up to 180. It doesn't matter if the lines are parallel or not. They always add up to 180. So same thing here. We could find X, but I don't think we have enough information to find Y. Anybody have a suggestion for how we could find Y? Other than break out a protractor and measure it ourselves? I don't think there is a way to find it. Okay, so answer Frank's question. Do corresponding angles always have equal measure? No. Only when? Only when the lines are parallel. We're going to be doing a lot with conditional statements in this unit, and we're introducing the idea of a conditional statement right now. This isn't a major learning target for today, but it's something that we'll kind of see over and over again, and eventually we'll make it the focus of a lesson. But let's just introduce it. A conditional statement is just an if-then statement. If something is true, then something else is true. And when it comes to corresponding angles, if the lines are parallel, then corresponding angles are equal. If lines are parallel, then corresponding angles are equal. I'm going to show you a way, we'll see this in the next lesson, but a little preview. We actually can abbreviate this pretty significantly. I would write this on a piece of, if I were writing it out on like a homework assignment, I would say if lines are parallel, then corresponding angles are congruent or equal. The little arrow is kind of your if-then. Actually, I don't even need the word if here. The arrow takes care of the if and the then. All right, the last thing I would love for you to do is find X in each of these pictures. Now, some of these are a little tricky. I'm going to kind of walk you through the first one. Is 115 and X, are those corresponding angles? Are they vertical angles? No, they're not even in the same intersection. Is there a transversal that's connecting these two angles? No, so they can't be corresponding angles either. So how are we going to do this? So I'll show you my strategy. Here's what I would do. I would say that 115 is corresponding. I'm going to try and move this 115 up to this intersection. Okay, so this 115 is corresponding to this angle here, agreed? Write 115 in here. We know they got to be the same. How do we know? Because they told us the lines are parallel with the little arrow symbols. So we know those are the same. And then this new 115 that I just wrote, I think it has a corresponding angle in the intersection with x, doesn't it? 115, zoop, slides right up to there. So this would also be 115. How do we know they're the same? They're corresponding angles, and the arrows tell us the lines are parallel. Oh, I know how to find x now. X is supplementary to 115. All right. See if you can kind of do something similar. For this one, see if you can find a way to move that 53 degrees closer to the X intersection. Now, be prepared for there being some problems here that you cannot do. The instructions actually say if it is not possible, then explain why. So if there's something that can't be done, all you got to do is write a couple words that say why. Okay. So we did part A together. I'll let you guys work through the other ones. When you're finished with those, you are free to start your assignment. But again, I would do the smart thing. While this is fresh in your mind and you understand it, I would put some notes in your pink packet about it. Well, that's just me. No, we did not. And just as a reminder, I'm not gonna write notes up here for you to copy down. That's not the purpose of this. So I want you to do your own. I kind of forgot the camera was on when I was doing that. I want you to make your own notes. You guys, if you're feeling like you understand it, write it down in your own words. This is going to be a lot more useful to you 6 months from now when you're trying to remember stuff, if you can look back and it's described in a way that makes sense to you. I'll get you some answers here so that we can check. Oh, nice. Those are corresponding, so they must be equal. I'm pretty sure this one's not possible. Guys, can I get somebody to confirm this, because I haven't worked this problem in a while. I'm pretty sure B is not possible. I think this 53, I can move it to here, correct? Because these two lines are parallel. So I'm convinced that this is 53 and this would be 53, and I could find these other two angles too, but I don't think there's a way for me to transfer from here to here because these two lines are not parallel. We can't use corresponding angles for that. Corresponding angles only work if your two lines are parallel. We got a transversal, and they are corresponding angles, but we can't say they're equal because these two lines aren't parallel. So it's not possible because lines not parallel. Awesome. Okay, learning target for today was, can you identify a transversal in a picture? We feeling pretty good about that? There can be lots of transversals in a picture. It kind of depends on what you're looking at. And if you can identify a transversal, can you identify two corresponding angles? And what's special about corresponding angles? They are equal, but only if the lines are parallel. So see how this is starting to get kind of complicated? We are going to learn about same-side interior angles and alternate interior angles in our next lesson, and then later on we're going to learn about alternate exterior angles. And then we're going to learn about interior angles in a triangle and base angles in an isosceles triangle and all kinds of other angle pairs. So again, do yourself a favor and make sure you're filling this thing out as we go so that when this list gets into the hundreds of different things you got to know, you've got a nice resource where you can find that information. The rest of the time is yours to work on the assignment. Ooh, that's a good chunk, 22 minutes today. I would love for you to get it done. Please let me know if you've got any questions on anything. I will be around